Hello everyone, this is a video on L'Hopital's rule. I have it currently in Unit 4. This is from Chapter 3 of the calculus book, which is why it says C3. But L'Hopital's rule is used to evaluate limits. Here are the objectives for this video, and a little Chuck Norris joke. I included this information because L'Hopital was actually a person, and this is what he looked like. He was French. Guillaume François Antoine Marquis de L'Hopital, in my terrible French accent. You can stop this and see some of what he did. But he's an actual person. So L'Hopital's rule has a condition, an if and then a then. So the if part has to be true before you can apply L'Hopital's rule. And that is that as you take the limit as x approaches c of a function, of a function over a function, it has to be of indeterminate form. And the most common one that we will use in calculus AB is 0 over 0. But we could also use another form of indeterminate, and there are several. And you will use those in subsequent calculus courses. But another one is infinity over infinity. So remember that these are indeterminate forms, and so they have to be that as well. The other notes on this rule are listed here. Please take a second to jot some notes down on here. The most important thing is you have to check for indeterminate form. It can be used when other techniques don't work, but it can also be used when other techniques do work. And it can be used more than once as long as when you apply it, you get another indeterminate form, and this is not taking the derivative. So this is our first example. We are taking the limit as x approaches 3 of this rational function. And normally what we would do first whenever we're wanting to evaluate this limit is that we would use direct substitution. So we would substitute a 3 for x. And when we do that in the top, if we took the limit as x approaches 3 of just the top, we would get 0. And then if we took the limit as x approaches 3 of the function on the bottom, on the denominator, we would also get 0. So that's one way that you could write that. That's indeterminate form. You would not put equals 0 over 0. Like, you're not allowed to do that. You could, however, in shorthand, and what I tend to do is this, where we apply the arrow. We say that the top trends to 0 and the bottom trends to 0. So that's indeterminate form. So in the past, what we have done is we used algebraic manipulation. We factored in, we canceled. So once that was 0 over 0, we said that the limit as x approaches 3 of the top, we would factor the top and we would factor the bottom. This is x plus 3, x minus 3. The top is x plus 4, x minus 3. Right? We would cancel and then apply direct substitution again, which would get us 7/6. So to do this using L'Hopital's rule, we would not set it equal, but we would apply it because it's indeterminate. And we would take the derivative of the top over the derivative of the bottom. We would apply direct substitution and get 7/6. Example number 2, if we use direct substitution and we plug a 6 in, we get 0. And we substitute 6 for x, we would also get a 0. That is indeterminate form. So what we did in the past, and what you could still do, I have students who still do this. It's a little bit longer, but it still works, right? So we have the function. You would multiply by the conjugate in the numerator. Conjugate is the same thing as what's in the top, but with a plus, and then form of 1, so we would use the same thing in the denominator. We would multiply those because the middle terms cancel, they'll go to 0. And so we end up with x plus 10 minus 16 on the top, and then we would have x minus 6, and then this, the square root of x plus 10, I'm going to run out of room, plus 4. Right? X plus 10 minus 16 is x minus 6. Whoops, and I forgot the limit. You can't say it's equal if you don't put the limit in there. And then I'm going to plug in the sixth, and I'm going to get 1 over the square root of 16 plus 4, which is 1/8. All right. By L'Hopital's rule, since I've already determined that it is indeterminate, then I'm going to take the derivative of the top over the derivative of the bottom. Well, the derivative of the bottom is just 1, so I'm going to kind of ignore it since I know that this is going to be 1/2 x plus 10 to the negative 1/2. Write it in simplified form, set it equal to times the square root of 16, which is also 1/8. So either of those will work. Another example is this one, where we are taking the limit as x approaches infinity. We learned before that this was the behavior at a horizontal asymptote, but there's 2 ways, of course, to do this one. Actually, I can think of 3. But if I put this in here, right, I'm going to get infinity for the top, and I'm also going to go to infinity in the bottom. Then that is also an indeterminate form. So L'Hopital's rule does apply to this problem. But another way that we learned to do this was to divide each of the terms by the highest power, which is x squared. So we've got 5x squared over x squared. I'm just going to write all of these over x squared. And then remember the big little principle. It's hard for me to write and talk. Hold on. Okay, so that if I have a higher denominator, this goes to 0. So all of these here go to 0. This cancels, and I'm left with 5/3. Which, of course, we saw this if we were doing the horizontal asymptote, we would have come up with that fairly easily. But we can also use L'Hopital's rule. So I want to show how this works as well, since this was an indeterminate form that's not 0 over 0. So I'm going to take the derivative of the top of the numerator, and I'm going to take the derivative of the denominator. Yes. And then I'm going to apply this again, and that would get us indeterminate form, right? It would be infinity over infinity. And then if I apply it one more time, because I could do it more than once, I would have 10 over 6, which is 10 over 6, which is also 5/3. So if you can remember how to do the horizontal asymptote, that's probably the easiest, but here's how L'Hopital's would be applied. The other thing about this example is that you can apply L'Hopital's as often as what you reach is indeterminate. That's kind of important. Our last example is the limit as x approaches 0 of sine 6x over 4x. And so if we do that, I'm going to just rewrite it right here really quickly. Sine 6x over 4x. If I apply 0, that would be 0 over 0, which is indeterminate. And so the limit as x approaches 0 of 6 cosine 6x over 4, well, the cosine of 0 is 1, so that's going to be 6/4. And you kind of notice that in here. Remember the identity that we came up with earlier? You could still approach it that way, but L'Hopital's also works. So would you use L'Hopital's every time? No. But as a recap, remember that you must directly substitute and get an indeterminate form before you can use L'Hopital's. The other reason that you always use direct substitution first is because sometimes that solves the problem. You don't need another technique. And so that's another reason to always substitute in first for a limit problem. And then the other thing that's really important to problems like this is that L'Hopital's is just another tool in your toolbox to be able to solve limit problems. So I hope this helps, and we'll do a lot more practicing in class. See you then.